So this first one, we're not going to solve it, but I do want to see if you can set it up, okay? Because that's usually the tricky part, is setting up the word problem, right? It says Micah. Oh, look who it is. It's Micah. I didn't even do that on purpose. Made this before I knew you were going to be my student. I have a nephew named Micah. So often, like, I have a nephew named Gavin, right? The last problem was a Gavin. I just throw my family's names in on things. Micah went deep sea fishing last weekend. He caught tuna and swordfish. He caught a total of 10 fish. The tuna weighed about 4 pounds each. The swordfish weighed about 10 pounds each. When he weighed all his fish together, it weighed 52 pounds. How many of each fish did he catch? Okay. First of all, if you can define variables, that's helpful. What variables are you going to use right now? T for what? P? P for what? Oh, pounds? You could do that, but that's not going to be what it's representing necessarily. You could use P. I would not. You could use X and Y. I would use something different. Would anyone else use something different than X and Y? T and S. Good. I would say T is, oh, sorry, we got to unplug. T is the tuna. S is the swordfish, right? Okay, so tell me one of the equations that you would get on this problem. Remember, you want to keep your things together. If it's dollars, we want all the dollars together. This is not dollars, this is pounds.
4T plus 10S equals 52.
Yes, so the weights, right? 4T plus 10S equals a total weight of 52. Does anyone see the other equation that you can write? Which number have we not used yet? Yeah.
T plus S equals 10.
Beautiful. There's a total of 10 fish, so tuna plus swordfish should be 10. Okay? If you want to try and solve that on your own, you go right ahead. It should work out when you solve it to 2 swordfish and 8 tuna. I'm not going to work it out right now because I want to make sure we get through all this, but I want to make sure you're good on the setup. Okay, so the first thing we're going to do, this is all about linear inequalities. Remember, what is an inequality? Less than, greater than, less than or equal to, greater than or equal to, right? Those are inequalities. What does it mean to be linear?
Straight.
A straight line, right? If you have a linear inequality, you have a straight line and it is less than or greater than that straight line, if you will. That'll make more sense as we go. So a linear inequality, when there are 2 variables involved, is like taking an equation, y equals x minus 3, but throwing in an inequality symbol instead, so y is greater than x minus 3. You know how to graph this as an equation, right? This is slope-intercept form. Now we're going to do it slightly differently with an inequality. I think it's beautiful. You're going to love it. Here's how this works, though. A solution of a linear inequality is an ordered pair, right? That's like this, x, y, okay? So a point, if you will, an ordered pair that makes that inequality true. When it's an inequality, it has an infinite amount of solutions, because if it just has to be less than something, you can keep going less than 1,700 forever and ever and ever, right? You can go into the negatives and whatnot. So different than, not different than a line, because a line goes on forever too, but you will have a plethora of possible solutions, okay? There are a lot of possible solutions here. So the first thing we're going to do, this is pretty straightforward. I think you could all do this without me even telling you what to do right now, is this. It says, is the ordered pair a solution of y is greater than x minus 3? Can you tell me right now, what is x? 1, okay? You have a point, x and y. I want to know, is that point a solution? So what are you going to do?
Plug it in.
Plug it in. So we're going to say, is 2, right? That's our y value, greater than 1 minus 3. So I plug my x in for x, I plug my y in for y, and then I simplify and see if it's true. Is 2 greater than negative 2?
Yeah.
Yes. As long as that is true, then you would say, yes, this is a solution. Okay, so plug in negative 3, negative 7, and then tell your neighbor if you think it is true or not. Nobody's talking to their neighbor. Did you figure it out? Who thinks yes? True inequality. Who thinks no? Not true. Good. So this is your x, this is your y. Negative 7 is greater than negative 3 minus 3. And these negatives can really throw you off, right? Because the number 7 is greater than the number 6, but these are negatives. So you got to flip-flop how you're thinking about it. A negative 7 on a number line is here. A negative 6 is here. Negative 7 is not greater than negative 6. So the answer would be no. Okay. Same thing on this next one then. You try A, we'll do B together after that. See if 3, 6 is a solution to y is less than or equal to 2/3 x plus 4. Let's say you don't have a calculator handy. How do you do 2/3 times 3?
3 over 1.
But how do you get that? How did you get to 3? Six over. Where you, are you talking about this is 6 over 1? This, so I want to know this. I want to know how.
I multiply 3 times 3. That's wrong.
3 times 3?
Yeah.
Yeah,
I was doing
no.
the thing where you had like.
You were treating it like a mixed number.
Yeah.
Yeah, nope. Okay, so here's the deal. If you're going to multiply a fraction by a whole number, turn that whole number into a fraction. Maybe that helps you to see it a little bit better, right? 2/3 times the number 3 is like 3 over 1, okay? When you multiply, you go straight across. So 2 times 3 is 6, 3 times 1 is 3, and 6 over 3 is 2. So this whole thing is equal to 2, right? The other way you could do it is you could cross reduce. 3 over 3 is 1, so all you're left with is that 2. Okay, either one of those is fine. Or plug it into your calculator. I don't care if you plug it into your calculator. But I do think it's important to know how to multiply a fraction by a whole number, okay? So we have 6 is less than or equal to 2 plus 4. So 6 is less than or equal to 6. Is that true? It is, because it has the equal to bar, right? As long as it has the equal to bar, they can be the same. Hey, Sophia, put that away. Thank you. So this checks out. This would be yes, that is a solution. Okay, try the next one. 10 is less than or equal to 2/3 times 6 plus 4. So what is 2/3 times 6?
2/3.
It's 4, right? You're going 2 times 6 is 12, and 12 divided by 3 is 4. So 10 is less than or equal to 4 plus 4, or 10 is less than or equal to 8. Is that true? No. So this is not a solution. Okay. Katie, did you have a question?
Well, because for for letter A and B, I just did like for letter A, I did 3 over 1, and I just multiplied straight across, and I got the same answer as you.
Yes, that's the same.
Okay.
Yeah, you can multiply straight across. You
Uh,
you just, yes,
Just put it.
and then
over
reduce, yeah.
one.
Mm-hmm. Okay, here's the fun part. Are you ready? I love this. When you graph a linear inequality, you're going to graph it like you're graphing a line, which I found you guys are really good at, so that's exciting. You graph the line in slope-intercept form, or you can do cover-up method if cover-up method works. But then your line isn't guaranteed to be a solid line. So what happens is you have to choose dashed or solid, dotted or solid based on what you're working with. If you have, did I not write this? I didn't. Sorry, you're gonna wanna write this in. If you have less than or greater than, okay, no bar, that is going to be a dotted or dashed, however you wanna think of it. I usually do dotted, but for some reason left dashed here. So that's a dotted line, okay? If you have this with the equal to bar, that's gonna be a solid line. Does anyone think they understand why one would be dotted and one would be solid? Yeah.
It's like when we did the dots.
Mm-hmm.
Because it's open and closed.
Yeah, it's just like the open and closed dots when you're graphing. The solid line means that line is part of your solution, right? The dotted line means the line itself is not part of your solution, but everything above or below it is, okay? So let's take a look at this. What you're gonna do is you're gonna graph the line. So if we're looking at this first graph here, right? We would plot this -1 right here. And then it's up 3, 1, 2, 3 over 2 would be this point. But because that is a greater than, not greater than or equal to, it's going to be a dotted line. Okay? Now, here's the deal. If it's greater than that, think greater than is above, you would shade everything above that line. So the yellow that is shaded. The way I like to do it, just to be totally certain that I have the correct thing, is I plug in a point, okay, so that's this part. I plug in 0, 0, and I see if it works, okay? Or you can do what I just told you, shade up or shade down. So what I like to do is I like to say, here's 0, 0. Let's see if that is part of my answer. So if I plug in 0 and 0, then I say 0 is greater than 3/2 times 0 minus 1. So 0 is greater than 0 minus 1, which means 0 is greater than -1. Is that true? Is 0 greater than -1? Mm-hmm. So if 0, 0 works, then you shade where 0, 0 is. But if this had been false, then you shade away from the 0, 0 point. So I would have shaded over here instead. Okay? Let's try it. Makes a lot more sense when you can just do it yourself. So you go here. We are going to graph y is greater than x minus 2. Maybe the first thing you want to do on this problem is just make yourself a little note. Is this a dotted or a solid line? This is dotted. So maybe you just want to write dotted so that when you go to graph it, you don't forget to make it dotted. Okay. What do you plot first here? The -2, your y-intercept. Okay. So we're going to go down 2 and we're going to plot a point. What's your slope of this line? It's 1, right? There's no number there, so the number that would be there is 1. Where do you move for a slope of 1? You move right. You also move up, right? So this is like rise over run. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. All of these are points on this line. Is it a dotted or a solid line? It's dotted. It doesn't have the bar. So make this a dotted line when you draw it in. Okay. Now it says y is greater than x minus 2. So what direction do you think you're going to shade? Up above, right? We're going to go up with it. The other way you can do it is you can plug in a point. 0, 0 would look like this, right? If I plug in the point 0, 0, then 0 is greater than -2. Is that true? Yes, that means this point is part of my answer. So I want to shade where that is, okay? I'm going to shade like this. You can use shading on Notability if you want to just actually shade it, but I'll show you in a couple days why I like this better. So this would be your graph. A dotted line, because it's greater than, and shading above or shading toward the 0, 0, because 0, 0 was true. Questions on that? It's fun, right? I love this stuff. Okay. Let's do this one. Where are you going to move first? Down 1. So down 1 right here. Is this going to be dotted or solid? Solid. It's got the equal to, right? So there's going to be a solid line. And then your slope is 2. So you're going to go up 2 over 1 for your slope. So up 2 to the right 1, up 2 to the right 1, like that. We said it's a solid line, so go ahead and draw that line in. Okay. If y is less than or equal to 2x minus 1, where are we going to shade? Below. And below right now would be this way. Okay. Or you could plug in 0, 0. 0 is less than or equal to 2 minus 0. 2 times 0, sorry, minus 1. So 0 is less than or equal to negative 1. That is not true. So we don't want to shade 0, 0, which is right there. So we don't want to shade above. We want to shade below. Okay. How are we feeling about that? Good? Okay. I'm actually going to skip that third one. If you want to try one more because graphing is a challenge for you, please try that last one. That's fine. That would be a solid or a dotted line? Solid. Yeah. Okay, but these ones, these are a little bit different. Remember in, what chapter? I don't remember. Where we graphed the OIVUX stuff. Chapter 5. I think it was chapter 5. When it was x equals something, what type of line was that? A vertical line. Okay. When it was y equals, it was a horizontal line. Okay. The same will be true right now. It's not an equal sign anymore, but it's still going to be the same type of line when all you have is that one letter. Okay. So graph this as if it's x equals negative 1. But then pay attention to dotted or solid and where do we shade, okay? So if x is greater than negative 1, is this going to be solid or dotted? This is dotted, okay? This is which type of line, vertical or horizontal? Vertical. So where x is negative 1, that's this line right here, we make a dotted line. Okay, now think about what it's saying. X is greater than negative 1. Are you going to shade to the left or to the right? To the right, right? We want it to be bigger than negative 1. So x is greater than negative 1. You're going to go like this.
You can't just like color them anywhere.
No, because it has to be true, right? Your x value has to be negative 1. Here's how you can check it. If I pick a point right here in the shading, that point has an x value of 1, 2, 3, right? That's the 0.32. My x is greater than negative 1. But if I picked over here, my x is negative 4. That's not greater than negative 1, right? So you want to make this true with your shading. Look at B. What type of line is y is greater than or equal to 2? It's solid and it's horizontal. So we're going to go a horizontal line at 2. If y is greater than or equal to 2, do we go above or below? Y is greater than 2. Above, right? We want to be greater than 2 on our y values. So like this point right here, for instance, that has a y value, 1, 2, 3, 1, 2, 3, 4. That's the 0.34, right? My y value is greater than 2. Okay, if I went down here, then my y value is less than 2. That doesn't work. So we don't want to shade below. We want to shade what makes it true. All right, x equals negative 5. That's a vertical line, right? And it is dotted because it's less than. So -5, 1, 2, 3, 4, 5. That's this line right here. If x is less than -5, where are we going? To the left. Did you sing it? To the left, to the left. Do you guys know that song? I'm so old. Okay, last one. Y is less than or equal to 2. Notice, very similar, right? Y is greater than or equal to 2. Y is less than or equal to 2. It's the same line. It's right here. But we shade where?
Oh.
Less than. We're going down with it. So that's here. Okay. All right, last thing. This one is a little not exact, if you will. It says you're having a Super Bowl party and you want to serve hamburgers and hot dogs, but can only spend up to $50. Up to $50. Not exactly $50. Up to $50. So you could spend 50, but you could spend 49 or 48 or 47, right? Anything $50 or less. A pack of hamburgers costs $4. A pack of hot dogs costs $3. Write a linear inequality to represent the situation, graph it, and then find 3 possible solutions, okay? So I'm gonna say it's $4 per hamburger plus $3 per dog. And we know that involves the 50. What inequality should go in between there? Less than or equal to. It's got to be less than or equal to $50 when all is said and done. Okay? So I'm going to put hamburgers here. I'm going to put hot dogs here. Okay? And we're going to graph this. Now, you can either graph it in like the cover-up setup, or you can graph it in the slope-intercept form setup. I'm gonna do slope-intercept, I think. Okay, so if you call this X and Y, just to help you see it. I would take away the 4x. So 3y is less than or equal to negative 4x plus 50. And then I would divide by 3. So y is less than or equal to negative 4/3 x plus 50/3. I'm going to write that as 16 2/3 or 16.6 repeating would be the same thing. Okay, now we can graph that, but it's kind of goofy, right? I'm going to count by 2's everywhere, or we're going to run off the page. So 2, 4, 6, 8, 10, 12, 14. I'm running out of space. I'm going to zoom way in. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. So if I'm going to graph this in slope-intercept form, what am I plotting first? What's your y-intercept? The 16 2/3. So this is where this is not super exact, right? Because we have 16 right here, we have 18 right here. So 17 would be here, so 16 2/3 is maybe like there, right? Not super exact, but it's okay. We're trying to just get some possible answers. So you're there, okay? And then your slope is a negative 4/3. So now let's think about this. We counted by 2's. So if I'm going down 4, I'm going 2, 4, and then I'm going over 3, 2, 3. Right? It's goofy. Okay, now we do it again. 2, 4, 2, 3. Do it again. 2, 4, 2, 3. 2, 4, 2, 3. So you end up with a line somewhat like this, which is totally fine if it's not exactly perfect, because the question was, come up with 3 possible solutions to the equation. Well, the possible solutions are not going to be fractions. You can't have a fraction of a hot dog and a fraction of a hamburger. That. So you pick a point that falls in your graph on the shading. If we want to be less than 50, it's got to be anything over here. That'll work, right? So what you're going to do is you're going to just pick a point. If I pick this point right here, okay, that is the point for 10. What does that mean? For what? Don't pack up, the bell didn't ring. 4 hamburgers and 10 hot dogs, right? So you can pick any point that falls in that shading, and that is an option. It's maybe not the best option because maybe you didn't buy enough for everyone, but it will work. So like if I picked this point right here, 8 hamburgers and 4 hot dogs, okay?